So we've already been introduced to phenols. It is a particular compound, which we could name hydroxybenzene C6H5OH, where the hydroxyl group is substituted for hydrogen and bonds directly to an aromatic carbon. But it's also used to indicate a family of compounds that have that hydroxyl bonded to the benzene ring. So phenol has some interesting history. It was formerly called carbolic acid, and it was found to be a very effective antiseptic. And it was when it was used to clean wounds in the operating room after operation, it dramatically reduced the number of post-operative infections. And phenol, if it has a lot, a if phenol is substituted with alkyl groups, then it's less toxic because it's less likely to be absorbed by the skin. So here are some structures on this slide of various substituted phenols, O-chlorophenol and P-methylphenol. So the O, of course, means that the two substituents are in the 1,2 position, and P means the two substituents are in the 1,4. And phenol means, of course, the hydroxyl. Like alcohols, the properties of phenols are influenced by the electronegative oxygen and hydrogen bonding possible through that hydroxy bond. It says here that they are somewhat water soluble. They're really not very water soluble at all. They're less soluble in water than alcohols, and you can get a small amount to dissolve, but it takes a lot of work and hot water. Many biomolecules contain this phenol group in it. So for example, tyrosine is an amino acid which is found in proteins. Eugenol is used for toothache pain. You may have heard that clove oil is good for toothaches, and that's because clove oil has eugenol in it. And then urushiol is the skin irritant in poison ivy. So 14.5 is just taking a little bit more time to look at the phenol structure in more detail and give you some examples of some naturally occurring phenols and a little bit of its history.